So hello students, in this video we are going to learn about the polar form and the Euler's form of a complex number. So before knowing the polar or the Euler's form, let's know the Cartesian form. See, Cartesian form. Now see, we know that a complex number z, any complex number z can be represented as a plus ib, where a and b are real numbers. And you know that this is the Argand diagram. This is how we draw the complex plane, in which x is called the real axis and this is x, the real axis, and y, the imaginary axis. Now this suppose is a complex number a plus ib. So if you join them, this is the modulus r and this is the argument theta. Okay, and you know that this thing, this part, this is the x-axis, which is the a, and this one the y, which is known as the b. So this is the b. Okay, so a complex number z, a plus ib, its r is the distance, or you can say the modulus of the complex number. R, this is represented as modulus of z, which is equals to under root of a square plus b square. And also how to find the argument theta. See, theta is the argument. So what we do is that to find theta, we take tan theta equals c. If you take this triangle, you know that theta is opposite by adjacent. This is b by, and so what will be sorry for this, let's write b by, and what will be theta? So theta is tan inverse b by, which will give you the argument. Okay, now the polar form. See, the polar form of a complex number, the polar form, or this is also known as modulus argument form. ODU, modulus argument form. So the polar form is r. We write polar form as r cos theta plus I sin theta. So this is the polar form, or in short we can write, we also write this as r c I s theta. So that's the polar form. Now what's the Euler's form? Now let's study the Euler's form. Euler's form or exponential form. Exponential form of a complex number. In Euler form, see, we write this as e to the power I theta, which is equals to cos theta plus I sin theta. Or we can also write, see, if there is this is a case when r equals to 1. Now if you take the modulus, so we write this, we can also write in Euler's form as r e to the power I theta, which is same as if I write this in polar form, same as r, this is cos theta plus I sin theta. Okay, now see, there are certain points that you should know. So first of all, you can have a look at this polar form or the modulus argument form. This is the polar form r cos theta plus I sin theta. In short, we write r cis theta, and this is exponential form r into e to the power I theta, which is r cos theta plus I sin theta. Okay, now we should know that what is, if I write what is cis pi. So see, cis pi, as we have learned just now, that cis pi is, you can write this as cos pi plus I sin pi. Okay, now what is cos pi? We know that cos pi is -1, so this is -1, and sin pi is 0. So this is actually equals -1. So you should know that CIS pi equals -1. Okay. Similarly, let's do what is CIS 0. So that's very simple. CIS 0, this you will write as cos 0 plus I sin 0. Now also we know that cos 0 is 1, and sin 0 is again 0. So this CIS 0 is actually equals 1. Okay. Now let's consider the case of in Euler's form again. E to the power I pi. See this, how you can write this e to the power I pi, that equals again cos pi plus I sin pi. So, oh, sorry for this, very sorry for this. Cos pi plus I sin pi. Okay, now we know that what's the cos pi? Cos pi is -1. So this is -1 plus sin pi 0. So e to the power I pi, that equals -1. Similarly goes with e to the power I 0. Now this you can write as e to the power I 0 is cos 0 plus I sin 0. So this is equals to what? Cos 0 is what? Cos 0 is 1 plus I sin 0 is 0 only. So e to the power I 0, that equals 1. So these points, you should remember these points, like these values. You can have a look. CIS pi is -1, CIS 0 is 1, e to the power I pi is -1, e to the power 0 is 1. Okay, and students, if you are enjoying the video, so please do like and subscribe, because your subscription really means a lot to me. So the next point, let's continue with our video now. So now, first of all, we should know what's a conjugate of a complex number. So conjugate of complex number. Now conjugate of a complex number, see, we know that in Cartesian form z equals a plus ib, where a comma b, that belongs to real, and the conjugate we used to write as a minus ib. So if we make this as an Argand diagram, and we know this is the x-axis, this one is x, and this one is y, the real axis and the imaginary axis. Now if this represents a complex number a plus ib, and you take this is in theta and argument, so a minus ib will be over here somewhat, a minus ib with the same distance, and but this angle is minus theta. So now see, we can consider that conjugate of a complex number to be mirrored on the x-axis. So we can consider the conjugate as a reflection on the x-axis. Okay, now for the polar form. Now what's for the polar form? Now see, we know that z, the complex number is represented as z equals r cos theta plus I sin theta. This is the polar form. Now again, if we look at this Argand diagram, we know that the conjugate is minus theta. So what we are going to do is that we just replace theta by minus theta to get the conjugate. Okay, so conjugate of a complex number will be r, this will be cos minus theta plus I sin minus theta, where theta, we take theta as an acute angle, but we know that cos of minus theta, because minus theta is, if you see, minus theta is in fourth quadrant, and in fourth quadrant cos is positive. So cos of minus theta will be cos theta, but sine of minus theta, sine is negative in the fourth quadrant. So this is r, this will be r, so you write this as cos theta minus sine, sine minus theta will be minus sine theta, so minus I sine theta will be the conjugate in that form. So, or in short form, if z is equals r cis theta, so its conjugate will be r cis minus theta. One thing that should be noted is that this Modulus, if it's a conjugate, the modulus remains the same. Okay. Similarly, if we take this in the Euler's form or the exponential form, we know that z is equals to r into e to the power I theta. That is, the complex number is represented as r into e to the power I theta. So the conjugate will be represented as r into e to the power minus I theta. So this is the conjugate in the polar form. Sorry, in the Euler's form. Okay, now let's do some examples, do some questions in which you have to convert these numbers in polar form. So you have to find the following complex number in polar form. Now the question is, find the following complex number in polar form. So see, you have given a complex number as 2 plus 2i. So now you have to convert this to polar form. We know that in polar form we write this as r cos theta plus I sin theta. Now if you compare the real part and the imaginary part, you see that r cos theta is 2, r cos theta is 2, and r sin theta is also equals to, taking this as equation 1 and this as equation 2. Now what do? We do equation 2 by equation 1, that is r sin theta upon r cos theta, that equals 2 by 2. So see, r and r will get cancelled, 2 and 2 will get cancelled to become 1. Sin theta by cos theta is tan theta. So this is tan theta equals 1, and theta is tan inverse 1. Now what is tan inverse 1? Now you are an IB HL math student, so you must be having your GDC, and you substitute in that, you get theta as tan inverse 1 when theta is pi by 4. So the argument of this complex number is pi by 4. Now what do? You substitute pi by 4 in equation 1 to get the value of this modulus r. So now substituting this will be r cos pi by 4 equals to, now what is cos pi by 4? Cos pi by 4 is 1 by root 2, that equals 2. So the cross multiplication r, this will be 2 into root 2. So that is r. So now we have the argument and we have the modulus. So we can write this as 2 root 2. You know the general form. As you can see, this is the general form, r cos theta plus I sin theta. So substituting the value of r, 2 root 2 cos argument is pi by 4 plus I sin pi by 4, or in short you can also write this as 2 root 2 cis pi by 4. So that will be the answer. Now the other complex number that they have given you is minus 4 minus 3i. Now again we'll do the same thing, comparing. We know that in polar form we write this as r cos theta plus I sin theta. Okay, now comparing the real and imaginary part, we see that r cos theta over here, r cos theta equals minus 4, and r sin theta, if you compare r sin theta, this is minus 3, this is minus 3. So let this be equation 1 and this be equation 2. Again performing the same thing, equation 2 by equation 1. Now see, this will be r sin theta upon r cos theta, which is equals minus 3 by minus 4. This is basically minus will become plus, R will get cancelled. So this is tan theta equals 3 by 4. Now what is the argument? Theta will be tan inverse 3 by 4. That's the argument. Now substituting tan inverse 3 by 4, we see that now I'm writing this in radians. Theta will be 0.64. So this is 0.64 radians. Now substituting the value of theta in equation 1. So this will be r cos, this is 0.64 equals minus 4. So r will be minus 4. And you see what is cos 0. Actually this will be cos 0.64. Now you substitute this in your calculator. That is minus 4 divided by cos 0.64. You should note that your mode should be in radian. So this is actually minus. My calculator is showing something like minus 4.9869. So this is minus 4.9869 and so on. So you can round it off to minus 5. So over here r is minus 5. So we have r is minus 5 and theta is 0.64, and we know the polar form. The polar form is this. They have given r cos theta plus I sin theta. So substituting the values, this will be minus 5 cos, this is cos 0.64 plus I sin 0.64, which is in the polar form, or you can also write this as minus 5 cis 0.64. Okay, moving on to the another question. Just solve one more question. Now they have given you the question that they have given you is 21 minus 20i. Okay, now again the polar form is what? R. This is cos theta plus I sin theta. So comparing this, we get r cos theta equals this is 21, this will be 21, and r sin theta. See, I'm again repeating that we are comparing the real and the imaginary part separately. So r sin theta, this will be a minus 20. As you can see, the minus sign, minus 20. Take this as equation 1, equation 2. Now see, performing the same thing, equation 2 by equation 1. So this will be r sin theta upon r cos theta. So r sin theta is minus 20 by 21. So r cancel, this gets tan theta. So tan theta we just write minus 20 by 21, and theta will be tan inverse. This is tan inverse 20 by 21. Okay, now see, now substituting this in calculator. So tan inverse 20 by 21, shift tan inverse minus, I'm sorry for this, here is minus 20 upon 21, bracket close. You are getting theta as minus 0.76. Now you can take either theta as minus 0.76, and if you want to convert it to positive. So see, the things that you should remember is, in case of tan, if you want that positive, what you do is that you just take this value 0.76 and add pi to it. So adding pi to it, so I'm adding pi. You use your GDC to get this. So theta is 2.38. So this is positive. Taking theta as 2.38 and substituting that in equation 1. So to find r, this will be r cos 2.38 equals 21. So r will be 21 divided by cos 2.38. So if you solve this in the calculator, So this is actually minus 29. R is minus 29. So we have R as minus 29 and the argument as 2.38. Now writing this in this form, so this will be, just a minute, this will be R is minus 29 cos 2.38 plus I sine 2.38. Okay, or you can write this as minus 29 CIS 2.38. So that's our answer. Now on to the last question of this video. So the last question is, you have to find the Cartesian form of a complex number. So they have given you a complex number in the form, this is the complex number in polar form, 5 CIS, this is 5 pi by 3. Okay, we know that we can expand this, so this is 5, you can write this as cos 5 pi by 3 plus I sine 5 pi by 3. Okay, now see, you must be using your GDC as you are IB Maths HL student. So you can directly find cos pi by 3, cos 5 pi by 3. So if you substitute cos 5 pi divided by 3 in the calculator, you will get 1 by 2. So this is 5, this is 1 by 2. And similarly sine 5 pi by 3, you substitute, you get minus 3 by 2. So this will be minus I root 3 by 2. Value of sine 5 pi by 3 is minus root 3 by 2. So now you can expand the bracket. This will be 5 by 2 minus I 5 root 3 by 2, which is in the Cartesian form. So student, that's all for today's video. Hope you liked it, and please, if you like it, please do like, share and subscribe with your friends also. And I will be coming with more such videos. So thanks for watching. See you in the next video. Bye.